All right, let's dive in. Today, we're going to take one of the most, let's be honest, frustrating parts of coding, getting an error, and turn it into an actual skill. We're going to learn how to decode those cryptic messages and start crushing bugs like a pro. So let's grab our virtual magnifying glass and get started. Oh yeah, you've been there. We've all been there. You write what feels like perfect code, you hit run, and bam! A screen full of red, intimidating text just stops you cold. It feels like a failure, I know, but I promise you that wall of text is about to become your new best friend.
I mean, look at this. This whole traceback message might look like total gibberish at first, but it is not a dead end. Think of it more like a map. The computer is literally trying to tell you exactly where things went wrong and why. This is clue number 1. Which brings us to the first big mindset shift we need to make. From now on, errors are not failures, they're clues. They're just a normal and honestly a helpful part of the entire coding process. Think about it like this. Your computer isn't judging you. It's a super literal machine that can only do exactly what you tell it to. So an error is just its way of giving you feedback, saying, hey, something about these instructions doesn't make sense to me. It's just a communication issue, one we can totally fix.
So the culprits we're hunting down usually fall into two main categories. On one hand, you've got syntax errors. These are like typos or grammar mistakes. The code just stops, and Python points right at the problem. Then you have the sneakier ones, logic errors. The code runs just fine, but the final result is completely wrong because the instructions themselves were flawed.
Okay, let's open our first case file. We'll start with the more straightforward of the two, the good old syntax error. Time to put on our detective hats.
So here it is, our first piece of evidence. Look really closely at that last line. The program crashed and gave us a syntax error. But notice how specific that error message is. This isn't just some random failure. It's a laser-focused pointer trying to help us out.
So how do we solve it? We just follow a simple 3-step investigation. First, the clue. The message literally tells us, word for word, a parentheses was never closed. I mean, it can't get any clearer than that. Second, the location. The traceback points us right to line 8. And third, the correction. Well, based on that, we just add a closing parentheses. And case closed.
All right, on to our next case. This is a classic Python puzzle, the indentation trap. Here, we're seeing a totally different kind of error, an indentation error. In Python, that white space isn't just for making things look pretty. It's actually part of the grammar. And if you get it wrong, your code will grind to a halt.
And you know what? We use the exact same investigative method. The clue is the indentation error itself. The location points right to the line that's missing its indent. And the correction is simple. Just add a tab or 4 spaces to fix the structure. See? This process is totally repeatable. Okay, now for a real challenge. Let's open the case file on logic errors. These are the tricky ones. These bugs don't announce themselves with a big flashy crash. No, they hide in plain sight, and they require a whole different kind of detective work.
Take a look at this. On the left, we've got the code, and on the right, the output. The program ran all the way through, no errors at all, but look at the results. It says energy is high for a potential energy of 9.8 joules. That doesn't seem right, does it? The logic itself is flawed.
So how in the world do we investigate this? Well, the biggest clue here is actually the lack of an error message. That tells us the syntax is perfect. The problem is in our thinking. We have to manually trace the logic. We see the if statement checks that potential energy is less than 1,000 to print energy is high. Wait a minute, that's completely backwards. So the correction is easy. We just flip the condition from p less than 1,000 to p greater than 1,000.
All right, you've seen how it's done, you've learned the methods, now it's your turn to be the lead detective on our final case.
Here's the code. It's supposed to loop through a list of heights and calculate the potential energy for each one. But it's broken. There's a bug hiding in there somewhere. Your mission is to find it. What's wrong with this picture?
Go ahead and pause right here. Take a close look. Run through it in your head and see if you can spot the problem. I'll be right here when you think you've got it.
And we're back. So, did you crack the case? If you had run the code, you would have gotten this name error. The clue tells us the name mass is not defined, and that's because the loop is trying to use mass, but we never actually gave it a value to begin with. The fix? A single line. Just add mass equals 1.0 right before the loop starts. And just like that, you've investigated 3 different types of bugs, and you solved the case all on your own.
You're well on your way. So let's wrap up with the core principles that are going to help you become a master debugger.
I want you to remember this detective's code. First and most importantly, errors are your friends. They are there to help you. Second, read the entire error message from top to bottom. The answer is almost always hiding in there. Third, trust the line number. It's your map. And finally, if there's no error message at all, that's your cue to put on your thinking cap and double-check your logic.
You now have the mindset and the method to take on any bug that comes your way. You've officially transformed from someone who sees a red wall of text and gets frustrated to a detective who sees it as a challenge. So, the only question left is, what bug are you going to go crush next?